Good afternoon, everyone. Thanks for joining. In this session, I will be talking about building customer identity and access management on AWS for B2C applications or customer-facing applications. My name is Mahmoud Matuk. I am a solutions architect with AWS. And as such, I work regularly with customers on building these applications or similar applications, different use cases, workforce identity, B2C, B2B, SaaS identity. And there are usually, in B2C in particular, there are usually themes of common features that all of these applications build on AWS. So in this session, I would like to share with you these set of common features and different ways or few ways of how they can be built on AWS. So here is the game plan for the next 45 minutes or so. This is a fairly technical session, so it's on the intermediate to advanced side of things. I hope you had a good lunch and you still have energy to go through this. And I will start by sharing these common scenarios that I see in B2C applications. And from there, we'll look at the bigger picture, and then we'll start descending down using a sample application to see how these scenarios can be built and can be implemented on AWS, different scenarios. And eventually, at the end, I will share with you the GitHub repository for the demo application. If you want to go offline and deploy it, it also has all of the automation and all of the steps to do that. All right, so customer-facing or B2C applications, the intention of these applications is that anybody on the internet can come to my app, create an account, and do business with me. So to make this happen, there are a set of features that these applications usually need to build, starting with self-service account management. So the first set of features, I want users to be able to come to my app, create account, sign in, sign up, do basic account management, account recovery, changing profile, multi-factor authentication. Many features and many things come under this category of features or category of capabilities. And this is usually the set of features that you get from an identity provider that you use. You can interact with it using the APIs, and you can build on top of these using the SDKs available to you. The second set of features is authorizing access to backend resources. So we usually don't authenticate users for the sake of it. We authenticate users because we want to give them privileged access to my backend or know exactly who are the users I'm interacting with. And eventually, we want to carry this session all the way to the backend and do authorization to backend resources. The third set of feature, which is specific to AWS, if you run an application on AWS, quickly you will realize that there is almost a service for everything you want to do. If you want messaging, if you want IoT, if you want analytics, if you want media, databases, and the list goes on and on and on. So eventually, to make your application more efficient and to benefit from all of this ecosystem, you need to get some sort of AWS credentials into your client so you can access and benefit these services from your handset or your client application, the browser, and all of these good stuff. So this is an area where I spend most of my time talking to the customers how to do this securely and how to carry these credentials from the AWS side to the client side. The third set of features, and naturally, if you get temporary credentials to access AWS resources, then you need fine-grained access control, how to make sure that these credentials are least privileges, how to make sure that I can do rule-based access control, attribute-based access control, and how to do this securely and in a scalable way. And the last set of feature is how to automate all of this. So it's not directly related to identity, but automation is something at the core of operating any successful application in production. And I just want to touch base on there are a bunch of resources and set of configurations you need to build to make this work and how to automate this and the possibilities that's available to you. So these are the common set of features that almost every B2C application needs to build. If you are running on AWS, you will also need temporary credentials and all of these good stuff. Now, let's look at the big picture, how these features can be implemented and which services, who's doing what in this picture on AWS platform. So on the left-hand side, I have my customer-facing application or B2C app. This could be a web application, a mobile application, a headless client on an IoT device, whatever client you are using for your customer-facing application. And I have a set of services and APIs living on AWS. Could have also backend outside of AWS in my own data center in another cloud. And I have a set of AWS services and resources I would like to interact with. I want users to be able to upload pictures or files to S3. I want to be able to use messaging services from AWS. If it's an IoT, I want to use IoT Core and a range of other services. How this happens at a very high level, your application needs an identity provider to authenticate users with. So this is the first set of features, which is the self-service account management. Cognito User Pool is an identity provider that is fully managed. You can integrate with it your client application, allow users to sign in and sign up. can also federate to external identity providers like Facebook, Google, social providers, and standard enterprise IDPs with SAML and OpenID Connect. It's fairly common in B2C applications to use social providers because you want to easy onboard users and allow large number of users to come into your application with easy onboarding. It's also fairly common using the federation to SAML and OpenID Connect, especially in B2B or SaaS situations where you want your enterprise customers to bring their own IDB. Cognito can do all of this business for you, and eventually your application receives Cognito standard tokens. The app then can use these tokens to authorize access to a wide range of APIs or backend resources, however you deploy them. We'll get into the patterns of this. The application also can use these tokens to interact with another Cognito service called Amazon Cognito Identity Pools. And the way you think about this as a credentials broker, that you come to it with an authenticated user, you already have a token, and then this returns to you a set of AWS credentials. You can cache these credentials on the client side, and then your application can use them to integrate and interact with the rest of AWS ecosystem using the AWS available SDKs. So at a 10,000-foot view, this is how all of these features can be implemented. Of course, we will take it down one by one and go into the details of this. Before I do that, a common question also is how my client applications can integrate with Cognito user pool. What are the available patterns and how to choose between them? So I want to get this behind us before we jump into the sample application. To integrate with the Cognito user pool, the first option available to you is using the OAuth 2 endpoints and using the user pool itself as an OpenID provider. This allows you to use the out-of-the-box hosted sign-in and sign-up pages. This is also the flow that you will be using if you are doing federation to social or standard IDPs. This is also the flow that you will be using if you are doing machine authentication with client credentials flow, for example. And the second approach is using an SDK and integrating with Cognito and doing basic authentication or standard authentication. And by this, I mean authentication using the standard factors, username and password, and the standard MFA like SMS or TOTP. There are different choices when it comes to SDK. There is an identity SDK. It's just a JavaScript that you can include in your application and interact with Cognito. There's also Amplify, which is a much larger framework that allows you to do integration with a wide range of AWS services and makes your web development journey a lot easier. So you can choose this if you wish to. Amplify Auth is the part of Amplify that interacts with Cognito. You can also do, using the SDK, you can do custom authentication workflow with Cognito. And this allows you to control or orchestrate the authentication process using a custom workflow. This allows you to do passwordless authentication, authentication using WebAuthn. You can do custom factors of your choice, automated phone call, integrate with anything that has an SDK. So using this approach, eventually you can orchestrate your own set of challenges and authenticate the user with anything that has an SDK. And the last approach is doing backend authentication or admin authentication approach. This is if you want to build your own identity service and you just want to use Cognito under the hood as an IDP for you. You can go into this pattern if you have a front end that is already in place and you don't want to change it, so you have fixed contract to interact with, or if you have more services to integrate with in your onboarding workflow, like if you have a user approval workflow that has human interaction and you want more control over this process. And as you see on the slider down there, the complexity and the operation increases as you go into this side. In reality, you might end mixing between all of these approaches. So for example, in our demo app, I'm using the second and the third approach, and I'm also using part of the first approach, which is social sign-in. But as you are evaluating how to integrate with Cognito, I'd say start from the left and make your way into the right. So start with the left and see, does this meet your feature set? Does this meet what you're looking for? If not, then move on to the next options. So this is a set of level setting and the refresher. Let's look at a sample application and look at these features again, how they could be built on AWS. This is a sample application. It's a contacts tracker application. This is a web app that allows anyone on the internet to come and create an account. It offers two tiers, a basic tier that allows users to just create an account, start creating a contacts list. It also offers a premium tier that allows users that are in this tier to message their contacts from the app. And then you can add features. Well, premium tiers also can share files with their contacts. or I have another Platinum tier that they can start voice conversations with their contacts. So let's see how these features or all of these buckets or categories of features can be built in this application, starting with the self-service account management. I'm going to show a quick video of how this works in action. And at the end of the slides, I have the GitHub repository for this. You can go deploy it, and you can look at all of the code and all of the automation there. So a user comes to my application, clicks sign up, normal stuff, just build your UI to collect the user information. This one allows users to onboard with an authenticator device to allow passwordless authentication. So there's also some logic to do this between the browser and the authenticator app. Signing up will send the request to the browser to activate an authenticator. All of this is WebAuthn. This is the standard WebAuthn stuff between the browser and the authenticator device. And then the data from the authenticator, like the public key and the credentials ID, all of this is stored as part of the user profile. Cognito then sends a verification code to the user, confirms the account, and then the user can sign in using a password or using passwordless, the way you choose. After signing in, an API call is made to display my contacts list. This user also wants to configure their multi-factor authentication, so they will go, generate a QR code, scan it with an authenticator app, and they are done. If this user attempts to sign in with a username and password again, they will be required to present their second factor. And they can still sign in with passwordless. You can do combination of both. You have the full control to do that. All right, so these are a set of self-service features that I offer to my end users. They can come, sign up for an account, sign in, change their profile, configure multi-factor authentication, and you can measure all of the other self-service actions using the same behavior. So let's take a couple of flows and see how this gets implemented. And again, as I mentioned, I'll share all of this with you at the end. The sign-up flow starts with building your own UI. You can design this with whatever web framework you are using. In this, I'm using Vue. You can use whatever web framework you would like to. When it comes to integrating with Cognito, all what you need to do is integrating with the Cognito using an SDK. So collecting user data, starting at line 15, this is where it makes a call to Cognito user pool to sign up the user and create the account. Cognito then sends a confirmation code to the email or the mobile phone, however you configure your user pool to do. And then you can use another API to confirm the user account and also confirm the communication medium that received the code, whether it's email or phone number. This is literally what it needs to be done to authenticate, to create a user with Cognito. And again, this is JavaScript. There are clients available in Python and Node.js and .NET, Java, whatever framework you are using or whatever technology you are using for your application. To look at this in a sequence diagram, what exactly happened, start the process with the user agent interacting with the relying party, which is your application, and just activating the authenticator so it can collect these credentials from an authenticator. This is WebAuthn stuff from step 1 to step 5. All of this is the standard WebAuthn. After this data and the other user profile data, all of this is sent to Cognito as a sign-up action, and then Cognito confirms the account, and that's it. Let's look at the sign-in flow. In a similar way, you build your own UI, collect the user credentials or the user username, and then make another call to Cognito to authenticate this user. Since this one is, you have different flows to authenticate the user. You have username and password, you have passwordless, or you have combination of both. There's some logic to choose which flow to go with. But at the end of the day, if you look at like line 19, this is the call that you are making to Cognito to authenticate this user. In this particular flow, Cognito is using custom authentication flow. So Cognito is going to respond back with a challenge and asking the front end to provide the response to this challenge. Once the response is received, the cycle goes back again. If you have more challenges, you can do that. If not, then the user is authenticated. To look at this in a sequence diagram, it will be a lot easier. So the process starts with the user agent or the front end collecting the credentials or whatever username that you would like to authenticate with and starting the process with Cognito. Telling Cognito that this is a custom authentication workflow. So in this case, Cognito moves the control to the custom authentication workflow, which is driven by 3 Lambda triggers. Lambda is just a code snippet that you can run serverless component inside AWS. The first stop or the first station at this custom workflow is define auth challenge. This is what it checks the user profile, makes sure that we have the data we need to authenticate this user using passwordless, like I have a public key from an authenticator device, and decides that there is a custom challenge needs to be presented, and this moves the control to create auth challenge, which returns the challenge to the front end, and eventually you interact with the authenticator device, collect the response to the challenge, and send all of this back to Cognito to verify it and authenticate the user. So I'm going to share with you the blog post at the end, and it has way more details to read through if you are interested in something like this. But using this workflow, you can orchestrate your sign-in process to do any kind of challenges you want. So you can integrate with anything that has an SDK. You can integrate with third-party MFA providers if you wish. You can use custom challenges, like solve an equation to sign in, anything like that. All right, so this is part of the self-service actions you can do, sign up and sign in. You can also measure on this all of the other actions, updating user profile, changing multi-factor authentication. All of these are offered as APIs available to you. These APIs are available through an SDK, and you can integrate with it from your client application. The second part is authorizing access to resources. So I was able to successfully create a user. I was able to authenticate the user and get tokens into my web app. How to use these tokens to authorize access to backend. In this application, the backend is all built on API gateway. So authorizing access to backend here means authorizing access to these APIs. You can build your backend in different ways. API gateway is one of them, but you can build it on containers. You can build it in custom virtual machines. It could be running in your on-premises anywhere else. I'll talk about the two common patterns. It's very common to use API gateway to build your backend or front your APIs because it offers out-of-the-box features for authorization that makes it a lot easier. But at the end of the day, authorizing access to backend is not much different than what you are doing today. You authenticate users, you get tokens, or you get a session, and you want to pass this session or token back to your backend for verification. The standard way to do this is passing the token in the authorization header. And if you are building your backend in API gateway, you have multiple options to do authorization there. So you have what is called Amazon Cognito Authorizer. And this means that on my APIs, I will just say that I want a token from this user pool. As long as the token is presented, the call will be allowed. You can also authorize access based on OAuth2 scopes. So as you see in the configuration here on the right-hand side, I'd say for the get contacts, so for this method under this resource, I want to enforce a Cognito authorizer, and I also want some OAuth2 scopes if I want to. All right? If you do this, zero coding, you don't need to code anything. API gateway automatically verifies the tokens, verifies that the scope exists, and will allow or deny the call accordingly. If you want to go and authorize access based on other things, you want to authorize access based on groups or custom attributes in the token, claims in the token, or maybe a combination between data in the token and backend services you have, or you want to go advanced and build a policy-based authorization engine, you can do all of this using AWS Lambda Authorizer. The way that this works with API Gateway is that the request is intercepted by this Lambda Authorizer, and then the token or whatever credentials will be passed in this Lambda Authorizer, and from there you can run the logic to verify the tokens, check what this user is authorized to do, and then allow or deny the call from the Lambda Authorizer. This is the approach if you are using API Gateway as your backend. And you can always, whatever backend you have, you can front this with API Gateway as a proxy if you want to offload this authorization part to the AWS services. On the other side, if you have a custom backend, like you build your backend on containers, or you have a backend that is running on your own premises or so, then at the end of the day, you will verify the tokens, decode the tokens, and do authorization logic in your application. There are multiple patterns for this. You can do this in a central authorization place. You can do this decentralized. You can do this in a proxy layer in front of your application. There are different patterns for this. But the essence of it is that you will receive the token, decode and verify the token, and make authorization decision based on data in this token. This is one of the libraries I'd recommend. It's our AWS JWT Verify. It allows you to verify tokens based on groups, claims, issuer only, verify tokens from multiple issuers. You can try it. And of course, there are larger range of libraries you can think of, depends on the technology or the language that you are interested in. So this is authorizing access to backend resources. It depends on how your backend is designed, But at the end of the day, you just pass this session or this token to your backend and verify it. Getting to the exciting parts, which is provisioning temporary credentials to AWS services. As I mentioned, as you run your application on AWS, at one point you will realize that, well, I need access to AWS services. I need S3, I need DynamoDB, I need SCQS, I need SNS. How to do this securely and how to get credentials to access these services from your client application. Our contacts tracker does this by allowing premium users to send messages to their contacts. So sending message literally with SNS is like 5 lines of code. This is rather than writing anything yourself. Let's take a quick look at how this works. A premium user signs in using passwordless. And the premium user attempts to text one of their contacts. And this sends the message through SNS. And you can trust my word that this message was delivered. How this works, how do I get credentials to access SNS from my client application, and how to do this securely, how to cache it, how to enforce fine-grained access control. This is what we cover in the next few slides. The approach to do this is that your application, well, let's just review the journey we have now. So the user signed up, the user was able to sign in, your application got tokens for the user, and then you are at the point that your application can take these tokens and go to Cognito identity pool and ask for temporary credentials. Cognito identity pool assumes a rule. What this means is that you define identity and access management IAM rules inside your account, associate them with a policy, and decide what this rule is allowed to do in your AWS account. And Cognito is going to assume this rule and return you the set of credentials associated with this IAM rule. All right? Once you get these credentials, you can call any AWS service you want according to the credentials or whatever permissions you have for this IAM rule. The coding part for something like this is really all of this. It is just few lines of code, assuming that you have already authenticated your user. Starting at line 3, you are creating an instance of Cognito identity credentials, and then you are passing the identity pool ID, and then you are passing the token you have and the issuer of this token, sending all of this data to Cognito and asking them for temporary credentials. Cognito will run through the logic to decide what kind of credentials this user, based on this issuer and this token, can get, and return these credentials if there is a path for that. Once you get the credentials, you cache them on the client side, and anytime you want to access an AWS service that these credentials allows you to, you just bootstrap your AWS instance like at line 6 here, AWS config.credentials, bootstrapping this with the credentials you have cached already, and then you can use the client of the specific service you want to access and make the calls. If the credentials you have allows you to make this action, the call will succeed. If not, you will receive an authorized exception. So if you think about this, you are offloading a great deal of authorization work to AWS. So you just write your policy, you get the credentials, you don't have to validate that the user has access to SNS or S3 or whatever, you just make the call, and if the user has permissions, the call succeeds. If not, it will fail. All right, so this is basically you authenticated the user, got tokens, used these tokens to get credentials, and make a call to AWS services. How about fine-grained access control? Well, I have basic user and I have premium user. How to differentiate between them? How to make sure that premium users can also call their friends that are only tagged as their friends. So how to enforce these fine-grained access control things, and what are the options available to you? Fine-grained access control patterns can be described in 2 patterns. There are branches to them, but for the sake of this talk, let's just keep it to 2 patterns. There is rule-based access control, which means that every user in your application, in your system, resolves to a rule. And this rule entitles them to certain things in your environment, period. So all of your authorization logic is to decide which rule correlates to this user. And once you assume it, the user can do everything that this rule allows them to do in your account. All right? This works well. It allows you to do fine-grained access control. If you have premium user, basic user, you have 2 rules, and you can do authorization based on this. But what happens if I have 300 rules? What if it's 3,000? What if I want to enforce access not just per rule, but actually I want to enforce access per user? I want to make sure that every user can access only the S3 bucket that they own, or download the file that they own. Then rule-based access control doesn't help you to do these scenarios. And this brings us to the other approach or the other pattern, which is attribute-based access control. Attribute-based access control means that access is allowed or denied based on comparing characteristics on the principal side with characteristics on the resource side. And if the condition meets, then the action is allowed. If it doesn't, then it's denied. For example, here, both of these users are part of the same rule. Maybe both of them are premium users. But only the user with green tag is allowed to send messages to the green queue. We can take it a step further and say that the user is allowed to send messages to the queue as long as the color of the tag matches each other. So now your policy is scalable and you don't have to worry about any hard-coded values. So let's see in our application how these things can be done and how these things can be done with Cognito identity pools. Back to the journey we have. My application allowed the user to sign up, sign in, get tokens. Application now has these tokens, and the app can go to Cognito identity pool and ask for temporary credentials. Cognito identity pool then have to decide which IAM rule to assume. In other words, doing rule-based access control. And for this, you have 3 options. The first option is using default configuration, which is simply authenticated and unauthenticated rules. So if you want to treat users in my system as guest user and authenticated user, this is the default configuration. You don't need to do much with this. The second option, if I have multiple rules, is choosing the rule from the token itself. So the incoming token has a value that indicates what is the IAM rule to assume. And this option is exclusive to Cognito user pools. If you are using Cognito user pool as your identity provider, you can define groups in the user pool. You can associate a rule with every group, and you can define rule precedence, meaning that if the user is a member of multiple groups, how to resolve this. And during authentication time, Cognito user pool will run through this logic, decide which rule is preferred, and adds this to the ID token of the user as Cognito preferred rule. And then you can instruct your identity pool, if you receive a token of this type, just choose the rule from the token. This will make your Cognito identity pool configuration simpler, and then all of the authorization part moves to Cognito user pool to the IDP. All right? As I mentioned, this is exclusive to Cognito user pools. What if you have another identity provider? Or you just want a generic option? So choosing rule with mapping rules is the third option. And this allows you to say that if I have certain claim in the token, and the value of this claim is X, then select the rule X. If the value is Y, select the rule Y. To make this clear, let's look at the visual representation of these rules. The first rule here says that if you have an attribute in the token or a claim in the token named custom subscription, and the value of the subscription is premium, then assume the premium rule. If the value is basic, assume the basic rule. And you can start stacking these rules, and Cognito will run through all of them. Not all of them, it will run through them in sequential order, and the first match will short-circuit the process and decide which rule to assume. If there is no match, then it goes to the rule resolution down there, and you decide whether to assume a default rule or just deny the call and say that I don't have a path to return credentials for this combination of token and issuer. And this is how you do rule-based access control with Cognito identity pools. Well, what if rule-based access control is not enough, as I mentioned? So my premium users here can message their contacts, but I want to add a flag. Maybe I will use this flag for quota management or for abuse prevention. So I want my premium users to be able to send messages only if the flag is true. So it's not just rule-based access control. I have to select a rule. I have to decide that this is a premium member and select the rule for them. But I also want to allow or deny access based on data or attributes in the user profile. Attribute-based access control in AWS is based on the concept of session tags. If you are not familiar with this, I recommend going to this link and just read more about it, but also follow along with me and I will explain this. But I would recommend this as an offline reading for you. Back to our journey, application authenticated the user, got tokens, taking these tokens and going to Cognito identity pool and asking for temporary credentials. Cognito identity pool will run through the process we described in the previous slide to select an IAM rule, in other words, doing rule-based access control. On top of this, you can add additional configurations to say that I want certain data from the user token to be available as runtime variables in my policy so I can write my policy according to these values. In this configuration, for example, I'm asking Cognito to make custom subscription claim, which is coming in the token, available to me as subscription. And this will be a variable in my policy. I can write my policy now in some way like this. So if you look at the condition at line 11, I'm saying that this action will be allowed as long as the runtime environment variable messaging enabled equals true. And this value is coming from the user token. So if I have 2 premium users signing in, both of them will be in the same rule, but only the user with messaging enabled true will be allowed to send messages to their contacts. And you can really be creative with these rules and write complex policies or write simple policies that can scale well. Just for the sake of examples, the first statement in this policy allows a client to execute an API gateway as long as it's accessing an API resource that is in the user profile and as long as the user is making the call against their own username. So I cannot make a call against other username. And these are just examples to show you what you can do with these principal tags or these runtime variables. The second statement is an S3 get. So this allows a user to get a file from S3 as long as the user is trying to access a file under a folder that matches their username, and as long as the file has a tag owner, and as long as the value of the owner matches the username. So this policy scales better. It doesn't matter if you have 10 users or 10,000 users. This policy doesn't need to change. And this is how you stack rule-based access control and attribute-based access control on top of each other to achieve fine-grained access control in your app in general. All right, so we need to build several resources to make this happen. We need to build a Cognito user pool, Cognito identity pool, several IAM resources like rules and policies and configuration between these. We need even to deploy an API gateway with an authorizer and all of this wiring to make this happen. And this is where automation comes into perspective. Automation universally is always a good choice to have or a good decision to have in your production application. You can do all of this from the console. You can run through this manual, but the next time you do it, you will miss something. So that's why usually, as you are building stuff, keep an eye on how to automate these things. And if I leave you with one information or one tip, all of the control plane action of all of the AWS resources have APIs. So you can always code against these APIs. You can use infrastructure coding like CloudFormation, Terraform, whatever you prefer. You can write your own Python scripts. You can write it with Java. You can write it with Node.js. So whatever you prefer, try to make automation part of your process for building these applications. In this particular application, I have a CloudFormation template that creates all of the resources. And this creates all of the backend resources needed, all of the Cognito infrastructure, all of the infrastructure on IAM and API gateway and all of these good stuff. I just bought the picture here for the sake of showing you what needs to be created. I know that this picture doesn't mean much to you. It just shows you that you need to build a set of infrastructure resources behind the scene, and it is better to automate this again than running through it manually. But once you run this stack, it gives you all of the configuration details needed to run your application or integrate with your app. You carry this over to your app, and this allows you to access these resources. Well, let's go back to this picture again, and hopefully this makes a lot more sense to you now after we walk through these steps. To do customer identity for your B2C application, the first step is that you need an IDP, and this can be Cognito user pool. Your application authenticates with the user pool and allows the user to sign in and sign up and do self-service actions as needed. Your application then receives the standard tokens, and these tokens can be used to access backend resources or send them to your own backend that is outside of AWS. These tokens can be also used to retrieve or request temporary AWS credentials from Cognito identity pool. In this case, Cognito identity pool will run through all of the authorization logic for you, doing rule-based access control, attribute-based access control, and returning to you a set of credentials that are scoped to whatever you have defined there. And then your application can use these credentials to access a wide range of AWS services as needed. I would leave you with few resources. So if you're looking for just basic information to get started and set of links, next steps, and so start with getting started. The link in the middle, this is the demo application. This is the GitHub repository that has all of the source code, all of the CloudFormation templates. It has the steps for how to deploy this if you are interested in deploying it and running it yourself, or if you are interested in diving deeper into the code as well. And if you are particularly interested in the custom authentication workflow or how WebAuthn works and how to do this passwordless authentication, you can do this with, you can access a blog post here. It has all of the information you need to build this as well. And that's pretty much it in my presentation. I think we have more time for questions and answers, so I would like to invite you, if you have any questions, to go ahead and ask. All of the things available with APIs. So if you want to delegate the administration of identities in Cognito user pool to some users, first option is to allow them access to the AWS console. Like you can give them a customer service rule or something like this, and you can craft a policy that allows them to only view identities, don't delete anything, change attributes. You can do this with the IAM options that we have today. Or using the admin APIs, you can build your own interface that allows a customer service rep or so to access this data and maybe like unlock a user or change address for a user or things of this sort. So the APIs path is available, the console is available, and you can use IAM to restrict access to whatever set of permissions you need for your customer service rep. Well, if you have another user, another identity provider, you can still use Cognito identity pools to get temporary credentials into AWS. So your users will authenticate with IDB 123, and then you have a standard SAML or OpenID token. You can use this to get temporary credentials from Cognito identity pool and continue to use the rest of AWS services. If you want to use this token also to access API gateway, then you can use Lambda authorizer. You can verify this token against the issuer and run your business the way you want.
And we still have time for a few more questions, but before you leave, be sure to come up and get a Cognito t-shirt. Give them away. We have from small to XXL. Back to you.
Yeah, go ahead. Thanks, Kevin. Sorry? Log out? Yeah, by logging out, we invalidate the refresh and the access token of the user, so it cannot be used against Cognito APIs. But as you know, in any token-based authentication system, once tokens are stamped and signed, they are considered valid until they expire. So if you take this token and present it to a backend, the backend doesn't necessarily go to the IDB and ask about it. So they can just validate the signature and the validity of the token. So the sign out in this case invalidated the tokens in Cognito perspective. They cannot be used to change user profile. The refresh token cannot be used to get additional tokens. But if you are using this to access a backend, then the backend may continue honoring this token until it expires. Yes, you can configure the access and ID token between 5 minutes and 24 hours, and the refresh token between 1 hour up to 10 years. Sure. Any other questions? Well, if you try the app and you have any questions, or even if you have any questions, make sure that you visit us at the booth. We have SMEs there that can answer your questions anytime. And I would like to also invite you to our session tomorrow at 2:30. We'll talk about running CIAM solutions at scale. And I will be joined by presenters from the National Health Services of the UK. They will talk about how they successfully ran NHS login at scale during the pandemic. So this is a very good story and very good lessons to take home if you are running things in production. All right. Thank you, everyone. Thank you.